Hello. There we go. Okay. All right. Literal equations, okay? Now, literal equations. A lot of what literal equations deals with is formulas, okay? A literal equation is basically an equation where they're going to remove a lot of the numbers, and you're going to see, all right, thank you. All right. They're going to remove a lot of the numbers. You're going to see a lot of variables, okay? And a lot of times literal equations deal with formulas, okay? And being able to rearrange formulas, if you will, all right? The thing that's going to be uncomfortable about today is when you start just moving letters around and adding and subtracting letters or multiplying and dividing with letters, you can't really kind of bring them together like you do like 2 times 3. 2 times 3 is 6. But if I say x times y, it's just xy, okay? And you'll kind of see that. But I'm kind of preempting you here that there's going to be part of this that's going to be kind of easy, but it's going to be a little bit different and uncomfortable in a way, all right? So let's start right here. I'm going to start here on the left, all right? What I have here on the left is just a basic 2-step equation. We have done these, okay? And we've talked about solving equations. If we were going to start solving that equation there on the left, what would you do first? You'd subtract 4, right? We would subtract 4 because we know, and we've talked about, we want to isolate the variable term. We're trying to solve for x. The x is involved with that 2 right there, so let's get that 2x by itself. So you guys know we're going to undo addition with subtraction. Subtract 4 from both sides. 2x is now equal to 6. And then to solve for x, how do we get rid of the 2? Yeah, we do division because we're undoing the multiplication. And 6 divided by 2 is 3. Very standard, straightforward, 2-step equation. And we are solved for x. Okay? Now, on the right, okay, it's the same equation. We're going to solve it for x, but what I did on the right is I removed the 4 and the 10, and in those places you're seeing a y and a z. We are still going to solve this equation for x. And guys, we're going to use the same steps. The solving steps are going to be the same. Over here on the left, we subtracted 4 first. So on the right, what are you going to subtract? You're going to subtract y. So watch this. We're going to subtract y from both sides. Bless you. Because again, the objective is the same. Isolate the variable term, 2x. We want to isolate that. Y minus y, gone. Now, this is the part where it gets a little weird and a little uncomfortable for some, because over here on the right, we're going, okay, z minus y. I can't do z minus y and get another letter, so the best we're going to do is just write it as an expression, z minus y. My apologies. I don't know why it has so much trouble connecting in the morning. It's something about the mornings. Okay? So on the right-hand side, we've got z minus y. Okay? And for some, it's like, well, gosh, what do I do there? Well, that's all we can do. Until they tell us what z and y are, that's all we can do. The solving step is still the same. We're going to divide by 2. So we're going to divide both sides by 2. That's going to leave us x by itself on the left. And on the right-hand side, we've got the expression z minus y divided by 2. And that's the best we're going to do. Okay? If 2x plus y equals z was some kind of a formula for something, all we've done is we have rearranged that formula per se so that we know what x is equal to. Okay? We've solved it for x. We've rearranged it for x in terms of x. Okay? That's it. And again, we are so used to some kind of finality with a number going, hey, I want a number for an answer. And we're not getting it. So that's kind of the uncomfortable part about this. Sorry about that, guys. Okay? Any questions thus far? Okay. All right. Let's go here. What you are seeing here is the distance formula. Distance equals rate times time. Okay? Simple formula. We're going to solve this for R. Okay? Let's say that you were getting ready to get an assignment where I'm going to give you a bunch of distance problems. And I'm going to ask you to find the rate. I'm going to give you the distance. I'm going to give you the time. I want you to find the rate. And so something that you might think to do is you might go, you know what? I got this distance formula. Why don't I rearrange this formula and solve it for R, which is rate, so that now I have a formula that will give me the rate. It'll give me what R is if I know the distance and time. And that way I can just plug in distance and time, do the math, and it will give it to me. Okay? All right? So distance equals rate times time. If we're going to solve this for R, how do you get rid of that t? If that's rate times time, and we're trying to get R by itself, how do you get rid of the t? You divide, right? We undo multiplication with division. So what I'm going to do here is I'm going to divide both sides by t. I'm still using equation operations, okay? T divided by t goes away. There's my R. On the left side, we have distance divided by time. Yellow. Where you at? There it is. I know. I don't know what it is about today. I may have to unplug the Apple device here momentarily. Okay? So now what you've done is we have rearranged, we have solved the distance formula for R, which is rate, and now when you get those problems, when we get those distance problems and the only information that you're given is distance and time, guys, rate is equal to distance divided by time. You're going to take the distance number and you're going to divide it by the time number, and that's going to equal the rate.
What's the letter on the top?
D. Okay? So again, just, this is where literal equations has a little bit of value per se. Like I said, typically it's used for you to rearrange different types of formulas or forms. Okay? All right, so far so good? Okay, what I'm going to do is because we're rearranging a lot of letters, I'll just try to give you some variations here. Okay, all right, let's jot this one down. All right, like I said, I'm going to try to give you some variations here. Okay, so we might be able to kind of see how we handle certain variations, certain setups. We've got y is equal to x minus h over k. Some of these might actually be on your assignment today. Might be worth jotting them down. We're going to solve this for x. Okay? Now, we're solving for x. Where is the x at? Top or bottom of the fraction? It's in the top. Okay, it's in the numerator. Now, here's the other thing about x. X is also tied up with that h via subtraction. X and h are kind of tied together with subtraction, and it's in the top of a fraction. Okay? Now, something like this. If you're after something in the top there, guys, we got to get rid of that denominator. Got to get rid of this fraction look. Okay? How do we undo division? Multiplication. So watch this. We're going to multiply both sides by k. I want to get rid of that denominator. Okay? All that crap on the top there is being divided by k. So let's multiply by k. And now those k's on the right disappear. And you are simply left with x minus h. On the left side, k times y is just ky.
It looks like a sideways.
I know, that's okay. Okay? Like I said, the uncomfortable part here is like when we subtract things, when we multiply things, when we divide things, we like some finality there, and you just don't get it with this stuff. Okay? It's kind of odd. It's kind of like you kind of feel like things are undone. If we're solving for h, what still needs to go away? The h. How do we get rid of the h? Going to add the h. That is x minus h. That is x minus h. How do we undo subtraction? We undo subtraction with addition. Now, you know, there you go. Get to bed. Okay. Now, we're solving for h. Now, I want you to look at something, okay? On the right side, all three of those items, pi, r squared, and h, would you agree that all three of those are being multiplied together? Yeah. We don't see any pluses or minuses. There's no addition and subtraction. There's no division. The pi, r squared, and h are all being multiplied together. How do we undo multiplication? With division. Division. We're solving for h, therefore,
Wait, can you even divide by? No, you can't.
we are going to divide both sides by the pi and the r squared. We can undo multiplication with division. We're going to multiply both sides by pi and r squared. The pi and the r squareds cancel each other out. H is now equal to 3v divided by pi r squared.
Oh. So that's just the answer. You can't go any further.
That's it. That's as far as we can go.
Because it's just h and there's nothing else on the other side.
Like I said, okay, with all these variables, with all these letters and things, okay, there's not much we can do. We are just simply rearranging these formulas, okay, using equation operations, okay? So the process that we use to solve equations, guys, we're sticking with that same process, okay? We're still undoing things with inverse operations. If things are multiplied, let's divide. If things are added, let's subtract. If they're subtracted, let's add, okay? But we are just undoing this and rearranging, okay? But something like this, there's a lot visually going on. We see a fraction, we see pi, we see r squared, we're thinking, oh my gosh, oh my gosh. Guys, get rid of that fraction. Get it out of there, okay? And really, this one ends up being a little bit easier than maybe what it looked like Because we can get rid of the pi and the r squared in one step. We can just do the division, boom, they're gone. Okay? Final answer right there. H, the height of that cylinder is equal to 3 times the volume divided by pi times the radius squared. Okay? Everybody okay?
Yeah, I think I actually understand.
It takes a little getting used to. I mean, it's kind of different. And there we go. We've disconnected. Do what? Okay. Next. There we go. There we go. All right, next. This is a popular one as well. Okay. This is the conversion for Celsius and Fahrenheit. Okay. What you're looking at here is in order to convert a Fahrenheit number, Fahrenheit temperature, to Celsius, this is the conversion, okay? And this seems to show up in different places, okay, where they want you to take this particular formula and we want to solve it for Fahrenheit, okay? So we want to get F by itself. Now, much like we did before, okay, notice where the F is. F's inside a set of parentheses, isn't it? Okay, now, we're going to have a little bit of instinct here to maybe want to distribute because we see parentheses. We have 5/9, unfortunately, that's a fraction, and it looks like it's being multiplied, so it might be, oh, God, I got to distribute this. Well, watch this, okay? Just like we did before on the previous problem, let's get rid of that 5/9. What would be the reciprocal of 5/9? 9/5. I'm going to multiply both sides by 9/5. Okay? And so before I distribute with that 5/9, let's get rid of it. Let's just remove it. So 9/5 times 5/9, gone. You've got F minus 32 left. On the left side, you have 9/5 times C. So on the left, you have 9/5 C. Okay? So get rid of that fraction. That kind of frees up that set of parentheses, so to speak. We don't have to take anything inside those parentheses, worry about multiplying with a fraction in there. We could, but just trying to save you a little bit here, okay? So now to get F by itself, we're going to add 32. F is now by itself 9/5 C plus 32. So there's your Fahrenheit conversion now. So if if we had a problem where they're giving you the Celsius the temperature in Celsius, we're going to take that temperature, multiply it times 9/5, add 32, boom, we got Fahrenheit now. Okay, so that's the Fahrenheit Celsius conversion formula. And all we did is we rearranged it so that we know now what Fahrenheit would be equal to, what the F is equal to.
No.
Well, if this is the worst thing that happens today, it'll be a pretty good day. Okay, any questions here? Okay? All right, we got one more. Let's go one more. This right here, this is area of a circle. Area is equal to pi r squared. Okay? And I know we haven't talked about this at any length yet, but I'll explain when we get there in just a second. Okay? Area equals pi r squared, area of a circle. They want us to solve this for r. Okay? So we want to know what radius is equal to. Well, a couple things to note here. Everybody agree that the pi and the r squared are being multiplied together?
Yeah.
Okay, pi and r squared are multiplied together. The r is being squared. Let's get rid of pi first. Let's try to get the r squared isolated. How are we going to get rid of pi? Divide. Right? Because pi and r squared are being multiplied, we are going to divide both sides by pi. Okay? So again, it's the same premise here. We need to isolate the r squared. That's the variable we're after, is r. Well, it's being squared right now. That's okay. But let's get r squared by itself at least first. Get rid of pi, and we're going to do that with division. Okay? Now, we've got area divided by pi is now equal to r squared. Does anybody remember what is the mathematical symbol that will undo something that is squared? What do you call that? You're right. It's a square root. The square root. Guys, r is being squared. A square root will undo something that is squared. So again, inverse operation, let's undo this. So we're going to take the square root Brad Pitt, there we go. We are going to take the square root of both sides, and the square root of r squared is simply r and so the radius of a circle is going to be equal to, take the area, divide it by pi, get that result, take the square root of that, we got radius, okay? But I wanted to go ahead and show that just in case you see something that's being taken to the second power and you're like, okay, how do I undo that, okay? A square root undoes something that is squared.
So now we have root and then a pi equals r.
We have the square root of area divided by pi
And
is
then
equal
that
to the
equals
radius. Yep.
Okay.
So if I gave you a bunch of, circle area problems and said, look, hey, we want to find the radius of these circles. I'm going to give you the area, okay? Then you can rearrange the formula and say, okay, look, you give me the area, Mr. King. I'm going to take that area. I'm going to divide it by pi on my calculator, and then I'm going to hit the square root button, and I got the radius, okay?